All right, what we are going to do is finish the sheet in this last video, and we are going to graph this fraction that has a removable discontinuity to it. So I know we started this at the end of the last video, but I'm just going to take it on again. So I see this fraction. I'm going to attack it the same way I normally would. Step one is I need to figure out what the domain is and also what my potential asymptotes are. So I've got x squared minus x minus 2 equals 0. And so when I factor this, I get the two factors of -2 that add up to -1 are -2 and +1. So x minus 2 equals 0, x plus 1 equals 0. So that tells me I have two problem areas. I've got x equal to 2 and x equal -1. They are both problems. I can summarize this in my domain, that I go from -infinity to this first value of -1, and then -1 to 2, and then 2 to infinity. So I have two places in my domain that are causing me problems. Now, in this particular problem, though, not both of those problems are going to be vertical asymptotes, because something else I notice is in the numerator, I have this thing that can be factored. It's a difference of squares. So the two factors of -1 I'm going to use are +1 and -1. We've already factored the denominator into x minus 2 times x plus 1. And so I see what happens here is I've got a common factor. I can remove one of the points of discontinuity, the x plus 1. So the graph of my original function, the graph of x squared minus 1 divided by x squared minus x minus 2 is equivalent to the graph of x minus 1 over x minus 2, with one exception. I have a point of discontinuity that I have to be aware of at the x value -1. So here's what I'm going to do. At the x value 2, I have a vertical asymptote because it's still in the denominator. So I'm going to do a vertical asymptote right here. And then what I'm going to do next is at this removable discontinuity, I'm just going to go ahead and do it now. I'm going to put my hole there. So what would the function value -1 be? What would the function value at the reduced fraction be? That's going to have the hole in it. Because remember, even though the function value of -1 exists for my reduced fraction, it doesn't exist for my original fraction. That's the problem. So in my new fraction, I have -1 minus 1 in the top. I have -1 minus 2 in the bottom. And so that is -2 over -3. So a negative divided by a negative is positive. So that at the x value -1, I've got a positive 2/3. So I'm going to put a hole instead of a dot right there. Now, what I'm going to do is the rest of the problem, I am going to do the rest of my 6 steps for graphing a rational function with this new reduced fraction. So now step 2 is, what are my horizontal asymptotes? Well, this is the situation where the power of the top, the degree of the top, the highest power is the same as the highest power of the bottom. So the horizontal asymptote is going to be y equals, the coefficient on the top is 1, the coefficient on the bottom is 1. So the horizontal asymptote is y equal to 1. We've seen that before in previous examples in the last video. So step 3 is I'm going to plug in 0 into my function. I'm going to figure out what my y-intercept was going to be. So in the top, I have 0 minus 1. In the bottom, I have 0 minus 2. So that's -1 over -2, or positive 1/2. So now I have a whole lot of information about what's going on to the left of the vertical asymptote. But before I get too excited, I'm going to finish and do step 4. Step 4 says, where does this go through the x-axis? Meaning, where is the fraction equal to 0? And again, all I care about is the numerator. So that happens when x minus 1 equals 0. And so that is at the x value 1. Okay, so the x value 1, so it's at 0. So Right now, what I can do on the left is I can say, oh, okay, this is going to go toward the asymptote there, and it's going to keep going toward the asymptote. You can see my removable discontinuity. I've made an assumption there from previous problems, but let's determine officially, does this go through the horizontal asymptote? Well, my value of my horizontal asymptote is 1. I'm going to clear the fractions on both sides of this by multiplying by my common denominator of x minus 2 on both sides. And we see that on the left, the reason I did that is those x minus 2's cancel, and I'm left with x minus 1. On the right, 1 times x minus 2 is x minus 2. And when I go to get all my x's on the same side, as we have before, we end up with a contradiction. So does this go through the horizontal asymptote? The answer is no. So to finish out this graph, I have one final thing to do. Step 6, I'm just going to get a point over here to the right of the vertical asymptote. So I'm going to plug in the value 3. So in the top, I have 3 minus 1. In the bottom, I have 3 minus 2. 3 minus 1 is 2. 3 minus 2 is 1. So I get the value 2. I'll do another one just for kicks. Let's put in the value 5. So when I put in the value 5, 5 minus 1 is in the top. 5 minus 2 is in the bottom. 5 minus 1 is 4. 5 minus 2 is 3. I get 4 thirds, so that's 1 1/3. And so we can see, oh, this is what this is going to look like. It's going to look like this, and then it's going to go, oh, just toward the asymptote. So there's my process for graphing a rational function. And in this case, the specific example of graphing my rational function that has a removable discontinuity. So I hope that's helpful. Hope you enjoyed it, and good luck.